Hey everybody, I'm going to try to make this as quick as possible, but we need to talk about monomials. The reason we need to talk about monomials, let's see if I can spell it, is because we are going to be working with exponents tomorrow, and exponents and monomials go hand in hand. We have rules for monomials that we learned many moons ago, but we have to remember them. So here's rule number 1. If you have a to the n times a to the m, then that means you add the exponents a to the n plus m. I know you hate my rules, so let's talk about what this actually means. If I have a to the third times a to the fourth, what that actually means is I have 1, 2, 3 a's here. And then because it's times, and I have 1, 2, 3, 4 A's here, then all I have to do is say I have 1, 2, 3, 4, 5, 6, 7, or A to the 7th. When you are multiplying with the same base, you add the exponent. So just throw another one in, x to the 4th times x to the 11th. I have 4 x's and 11 x's, so that's just going to be x to the 15th. Rule number 2 is division. If I have a to the m divided by a to the n, then I get a to the m minus n. For my C block, this is the one that you guys were not sure at all about. If you have x to the 7th divided by x to the 5th. What that actually means is I have 1, 2, 3, 4, 5, 6, 7 x's and 1, 2, 3, 4, 5 in the denominator. X divided by x is 1. All of these cancel out, thus leaving 2. And so if we subtract 7 minus 5, we get our x squared. If we have, I can't remember what I put, x to the 7th, y to the 5th over x to the 4th, y. I have 7 x's in the numerator, 4 x's in the denominator, so that leaves me with x to the 3rd. I have 5 y's in the numerator, 1 y in the denominator. This is actually a y to the 1st, so 5 minus 1 would give me y to the 4th. Okay, so I just messed up, so hopefully this makes sense, and Jeffrey's going to make fun of me tomorrow because I messed up in here, and so Sarah. So let's try again. This is going to be rule number 3. Rule number 3 says that if I have a to the nth power and I raise it to the m power, I'm going to actually multiply those two. Now I know that the whole rules don't make a whole lot of sense. So what this means is that I have x to the 3rd and I raise it to the 4th power. That means I have x to the 3rd once, twice, 3, and 4 times. My brain wanted to write 4. So I have 4 x to the 3rd. Well, everybody in here knows x times x times x. X times x times x. There's 6, 7, 8, 9, 10, 11, 12. So what you do is multiply so that you get x to the 12th. That's a really bad 12. You have y to the 5th raised to the 6th power. It's just going to be multiply those and get y to the 30th. Now, if you have for rule number 4, a to the 0 power, that is going to be equal to 1. The reason that anything to the 0 power is equal to 1 is because if I had x to the 3rd over x to the 3rd, that means I have x times x times x and x times x times x. These cancel out and leave me with 1. Well, our division rule says that 3 minus 3 is 0, because we should subtract if we are dividing. So anything to the power of 0 is 1. If I have x to the 0, it equals 1. If I have y to the 0, it equals 1. If I have 2x, y, z to the 5th, all raised to the 0 power, it equals 1. The 5th rule is that x to the negative n is equal to 1 over x to the n. Did you get your brother? Well, then don't shut that door because you can't get in. Sorry. Family feud. So what this means is if I have x to the 3rd over x to the 5th, remember our rule is to subtract when we are dividing. Well, if I have x times x times x, and 1, 2, 3, 4, 5, 3 of these cancel, and it leaves me with 1 over x squared. Well, if you subtract, this is x to the 3 minus 5, and 3 minus 5 is x to the negative 2. So what this means is that if it's negative, it goes into the, if it's negative in the numerator, it goes into the denominator. It also means that if it's negative in the denominator, if you have 1 over x to the negative 5, if it's negative in the denominator, then you can move it up to the numerator. That's rule number 5. The last two are awesome because they're commutative properties. I'll even put them on the same page. If I have m times n to the a power, I'm mixing up my variables, then I get m to the a times n to the a. Just means that we're going to distribute the a to everything. If I have m divided by n to the a power, then I get m to the a in my numerator and n to the a in my denominator. Once again, distributing that exponent to the numerator and to the denominator, to both terms. Now let's do something that makes a little more sense. If I have x to the 3rd, y to the 7th, and I'm going to raise that to the 4th power. Raising a power to a power, we multiply. So we get x to the 12th, y to the 28th. If I have x, y to the 3rd over, I'm sorry, this is rule number 7, over z to the 4th, and I raise that to the 5th power, then I get x to the 5th, y to the 15th, and z to the 20th. Those are the 7 rules of monomial. Hopefully this has been a quick refresher, and we will have a fabulous day with our rational exponents tomorrow. Goodbye.